What up, second period? Hope y'all had a great weekend and that you're having a good day. Today is April 28th. We're already in week 5 of online school. That's crazy. Crazy. Well, this lesson is for y'all who weren't able to make the class today, and if you also need a refresher before you try to solve the problems. So let's go ahead and jump into it. Today we're going to be learning about a new topic called molarity. And molarity, or molar concentration, just means how concentrated something is. So let's jump into some examples with pictures, pinturas, before we do some example problems. So some vocab that we need to learn beforehand. Solute, this word right here, ooh, I don't want that. Solute is going to be a thing being dissolved. So if we're talking, let's use the example of chocolate powder and milk. I'm sure most of y'all have tried this before. So the solute is a thing that's being dissolved. So in this instance, the solute is the chocolate powder because it is a solid that's going to be dissolved. The solvent is the thing doing the dissolving. Think of like, try to think of like a detective. The detective solves crime. The solvent dissolves the solution, or the solvent dissolves the solute. So the solvent here is going to be the regular milk, because the regular milk is going to dissolve the chocolate powder. The solution is the solute and the solvent combine to make whatever it makes. So if we combine the chocolate powder with the milk, it's going to give us chocolate milk, which is the solution. If it has a high concentration or high molarity, there's going to be a lot of chocolate milk. There's going to be a lot of chocolate powder that we dissolved in here. If it's a low concentration or low molarity, then it's going to be not so much chocolate powder in there. Okay, so let's look at dogs in a pool. So I don't have a dog, but I want one. All right, so solute, the dogs aren't being dissolved, but we can still use this example. So the solute would be the solid. All right, so the dogs are going to be the solute. The solvent's the thing doing the dissolving. The liquid carrying the dogs is going to be the pool water, and the solution is going to be the dogs in the water. So if we have two of the same pools, and we have the same pool twice, the high concentration of dogs will have the most dogs in that same given area. The low concentration of dogs will have only 2 dogs in that given space. So concentration is relative to the amount of space we have. Let's pretend that both these pools are the same size. If they're the same size, and I have 2 in each pool, then that means that they both have the same concentration. If one of them was bigger than the other, they would have different concentrations, even though they both only have 2 dogs. So this one has a higher concentration because there are more dogs in the same given space compared to this one over here, which only has 2 dogs in the given space. Let's go ahead and move on to some example problems with the Zeitboard. Okay, so molarity. Molarity is going to be represented by the letter M, and the equation for M, and so it also is called molar concentration. That represents the same thing. So molarity and molar concentration are the same thing. So M, the equation for molarity, is going to be moles of solute. That we're going to divide it by the volume of solution in liters. So we're going to take the moles of the solute, so we would take the moles of chocolate powder, divided by the volume of the solution, the chocolate powder with the milk, and that gives us our molarity, or concentration. So that's pretty much how we solve for molarity, how concentrated something is, how much stuff we have in a given space. So let's do some example problemas. Oh, before we do that, we need to write out our equations. So we have 2 equations to help us solve. That's equation 1 right there. Sorry, my mind is all over the place. That's equation 1 right there. And then equation 2. I'll make a 2 out of this. Good enough. So equation 2 is going to be MB equals the weight divided by the molar mass. So MB equals weight divided by molar mass. So M is going to be molarity, concentration. B is going to be volume in liters. Weight is going to be the weight of the solute they give us, or we have to solve maybe. And then molar mass we can find on our own with the chemical equation. That's going to be equation number 2. Let's go ahead and do an example problem. Let's go ahead and get this over here and move it over here and put that right there and bring it on over here. Okay. Let's change my color. What is the molarity of 904.94 grams of NaCl solution dissolved in 4.0 liters of agua, water? So let's go ahead and put N here because we're ending in molarity. We're trying to solve for molarity. It gives us volume, V, and it also gives us weight. So we're probably going to use equation 2 for this one because we're trying to solve here for molarity and give us weight and volume. And we can look at molar mass on our own. So let's go ahead and write it out. So M times V, which is 4 point. These are very similar to our gas law problems where we're going to plug stuff in and find what we need to and move the equations around. That's going to equal 904.94 grams. And then we're going to divide that. We can do that line. Molar mass of NaCl is 58.44. So 58.44 grams. So that's my molar mass. That's the weight they give us right here. That's the volume I got from right there. And then we're solving for M. Remember, we're using equation 2 right here. So I'm going to go ahead and get a number here. And I'm going to divide that number by 4 because it has to cancel out. So this is the same as if I had X, Y equals Z. Okay, this divided by that is going to give me a number. We'll call that Z. And then if I want to solve for X, I'm going to divide both sides by Y. And that will give me X by itself. Y cancels out. Divide by Y over here to equal it out. So I'm going to get a number right here for Z, 904.94 divided by 58.44. That's going to give me Z. And then I'm going to divide that by 4 to get M, because that's how it's going to cancel out. So let's go ahead and type that into our calculator. So do 904.94 divided by 58.44. That's going to give me 15.48 divided that by 4. So big M molarity is going to be 3.87 M. It's always going to be an M, big M for the units there. So the molar concentration is 3.97 big M. All right, that's 3.97 molar. Okay. Okie dokie. So that's my answer for that one. Remember, if you have any questions on Schoology, you can always message me or message me on your mind. Let's go ahead and do another one, 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 another one. Okay. What is molarity of 753.93 grams of H2SO4 solution dissolved in 200 milliliters of water? I'm going to put an N right here because I'm ending in molarity. It gives me weight. And it also gives me volume, but that's going to be in milliliters. I need to convert that to liters for my equation. So we're going to use equation 2 again for this one because we're solving for molarity. So let's go ahead and plug it in. So M times V. Now, to get this in liters, we have to move to the left 3 times. So we have to move that decimal to the left 1, 2, 3 times. So that's going to be 0.200, all right, liters for the volume. And that's going to give me my weight, 0.93 grams. And I'm going to divide that. Ooh, that should be a period right there. It won't, I'll just erase it and draw it over again. That looks ugly. Okay, so big M times 0.2 liters. Remember, it's 0.2 because you have to move that. If it's in milliliters, you have to move the decimal to the left 3 times to get it in liters. So that's going to equal 753.93 grams. I'm going to divide that by the molar mass. So the molar mass of H2SO4, let's go and type that in. H2SO4. What is the molar mass of H2SO4 wolfram alpha? Wolfram alpha says the mass of H2SO4, the molar mass, is going to be 98.07 grams per mole. So divide that by 98.07 grams. Okay, and so it's what we have here. So we're going to get this number right here. That's going to be Z, and then we're going to solve for M. So 753.93 divided by 98.07 gives me 7.68. I take that 7.68, divide it by 0.2, and that gives me big M by itself. Divided by 0.2. So my answer is going to be 38.44 molar. So that's my concentration. 38.44 molar. That's a very high molarity. That's a high concentration. So very, very, very high concentration. All right. Any questions here? Any answers? Okay, let's do one more, and then we will call it a day. And you can play your Snapchat or Instagram or whatever kids do these days. It's gonna be a little bit more difficult. Actually, no, this one's a little bit easier, I think. How many moles are there of NaOH in a 500 milliliter, sorry, 500 milliliters of a 4.00 molar solution? So we are looking for moles. That's gonna be my ending point. Gives us volume, and it also gives us molarity. Do I have moles? So I'm probably going to use equation 1 here. Let's go ahead and jump into it. So it's going to give me 4.00 molar equals moles of solute divided by volume. Remember, it has to be in liters, so we move it to the left 1, 2, 3 times. So 0.5 liters of solution. Simply multiply each side by 0.5 to get moles by itself. So 4 divided by 0.5 is going to be 2 moles of NaOH. That one was a very simple problem, but you get the gist of it. So my answer is going to be 2 moles of NaOH in this solution. Alrighty, okie dokie, that is all for today. The questions are going to be on Schoology, and you have till Friday night to get it done. Hope y'all are having a wonderful day today. Message me if you need help on Thursday. We will go over homework questions if you have them. So bring your questions for Thursday in the Schoology conference. And that'll be all, y'all. Hasta luego. Stay safe. Wash your hands. Oh, I gotta stop recording. Here we go.